Hello and welcome to today's class. For this class, we're talking about the concept of integration of trigonometric function using the concept of trigonometric identity. So we're talking about the case 4 that govern this concept. For the case 4, I'll be showing you the concept that guides the idea of using the case 4 under the idea of integration of trigonometric function using the idea of trigonometric identity. So your first task here is that if I have an integral of sine ax and sine bx with respect to the x, such that a has a larger value than b, that is a is greater than b. So if I have an integration of something of this nature, how do I go about it? If you recall from our last class, for our last class on case one was sine and cos. Case 2 was cos and sine. Case 3 was cos and cos, and why case 4 is now sine and sine. So for sine and sine, what is the mathematical expression? So for this one here, the mathematical expression becomes half integral into cos a minus b of x, attach x to it, minus cos a plus b, attach x to it with respect to the x. So this becomes the expression, the mathematical expression, when I have sine of something multiplying sine of another number with respect to the s. So this is how I express it mathematically. All right, let's use this concept to solve some example and let's see how it works. So example 1, let's say I'm taught to evaluate the integral of sine 5x. All right, let's use sine 15x instead. Sine 15x sine 5x with respect to the x. Observe that 15 here represents a here, and 5 here represents b. And observe that 15 and 5 they are not equal, right? 15 is greater than 5. So it means that the idea is that this one here must be larger in value than this number here. So how do I express this one? I'll use the same mathematical expression for this one here. So the idea is that let's get a, let's get b. What's a? Of course, a is 15. Let's get b here. B is 5 at this point. All right, let's express this one here mathematically. I'll be having that this is equal in value to half integral into, this is cos. I have cos a plus b is similar as what? 15 minus 5. But say a minus b, that becomes 15 minus 5. Attach s to it. This is minus, a minus sign here. This is cos. I have a cos into a plus b, that becomes 15 plus 5. 15 plus 5. Attach x to it, all into what there? The x. All right, at this point here, what's your next task? My next task, simplify. This is half integral into, this is cos. I have cos here. Into this 15 minus 5, we give 10. I have x, or perhaps just 10x instead. 10x. I'll use a round bracket here, please. A round bracket. So minus the minus sign here. This is cos. I have a cos into 15 plus 5. That's 20x. Sorry. 20x. So I have the x. At this point, our next task now is to use this half and integral to multiply through. So we're having my answer as half integral. Use cos, this is cos 10x. Attach the x to it. I'm done with this one. Pick out this. This is minus sign, minus. This is half integral, half integral, half integral cos 20x with respect to the x. So at this point here, what do I get? I'll pick out half. This half here into, if I integrate cos 10x, I'll have sine 10x all over 10. This is minus sign, minus. This is half. Half into, if I integrate cos 20x, I'll have sine 20x all over 20 plus c. This plus c, we call plus c constant of integration. At this point here, let's get final answer, please. At this point, 1 multiply sine 10x, I'll have sine 10x all over 2 times 10 will give 20. This is, oh sorry, this is minus. I have a minus sign here. 1 times sine 20x gives sine 20x all over 2 times 20 gives 40. Next up, plus c. This becomes my answer after solving this problem using the concept of case 4, as you can see. All right, see you in our next class.